Chapter 20 is all about water pollution. The case study that opens it up looks at Lake Washington, which is near Seattle. And I think one of the most important things to take out of this case study is that citizen pressure on elected officials is really what made things happen. And also the fact that it starts to introduce this idea of dilution is the solution. So sometimes when it comes to pollution, you can't get rid of it, but if you dilute it, think back to the dose makes the poison, right? So if you can so it's not as strong, that sometimes the best you can do. All right, so first section looking at the causes and effects of water pollution. So really important to understand the differences between point sources and non-point sources. So point sources are things that are coming from very specific locations like pipes, ditches, sewer lines, etc. So picture like a pipe letting water pollution out. Non-point sources are runoff from really large areas, could be parking lots, agricultural fields, etc. So if you think about it, which of those will be easier to control? Definitely the point sources. Major sources of water pollution, number one is agriculture. So with agriculture, you can get things like sediment pollution, fertilizers, pesticides, bacteria, salts, all can be problems when they get into water. Industrial facilities, chemicals, coal ash, fracking liquids, because there are a lot of chemicals that are used in fracking that can get into the water supply. Mining, you get erosion, toxic chemicals, acid mine drainage, and then even plastics can be a source of pollution as they break down into smaller and smaller polymers. And there's some pretty stunning pictures here of water pollution in different forms. On page 532, definitely know table 21, the major water pollutants and their sources. So you've got pathogens, oxygen demanding wastes, okay, so like biodegradable waste that could come from sewage, for example, plant nutrients, organic chemicals and inorganic chemicals, sediments, heavy metals, and also thermal pollution, heat pollution. Definitely know those should be in your notes. Also related to pathogens is the table right below that on the same page, where they give you some different examples of waterborne infectious diseases. I think it's really important to remember that about 1.5 million people die every year from infectious diseases that they get through water and polluted water sources. So the one that probably gets the most attention in the news is cholera, because there will be cholera outbreaks like there was in Haiti after the earthquake. And a lot of times places where poverty is already an issue, dealing more with this. The science focus box talks about different water tests. We've done some of these in the fall, and we'll hopefully do them again, assuming the weather cooperates, down at Ipswich River. All right, so second section of this chapter looks at pollution in streams and lakes. And this diagram right here on page 534 showing the oxygen sag curve, kind of the same idea as eutrophication, but imagine that there's a point source of pollution, like a leaking sewage pipe or something like that. Where that waste enters the stream, you see the biological oxygen demand, BOD, go way up because you have a lot of bacteria, et cetera, that are going to be breaking down that waste. And so the levels of dissolved oxygen drop way down. And then as you get further downstream, it starts to dilute more and you get bacterial activity and it kind of levels off. So as long as the stream is not overloaded, it can recover from that. In less developed countries, the major source of river and stream pollution tends to be untreated sewage. It can also be industrial waste and garbage, etc. It's not that laws don't exist, it's that oftentimes there's a lack of law enforcement when it comes to water pollution. Now, lakes and reservoirs will take a little bit longer to recover than a stream would, because the layers of the lake, kind of think about different temperature layers, reduce the mixing of the water a little bit. And there's, depending on the lake or reservoir, little or maybe even no flow. So they could be more vulnerable to pollution. And then we've talked about eutrophication multiple times this year. If you need a reminder, it's on pages 536 and 537 with a picture of a very algae-covered lake But remember the end result, right? Too many nutrients and you end up with not enough dissolved oxygen. Then we get a great case study on pollution in the Great Lakes. So read through that. All right, 23 deals with groundwater pollution, which can be very problematic because groundwater and aquifers in particular do not recover very quickly because there's very, very, very slow flow, little dissolved oxygen, temperatures tend to be lower, there's less bacteria that can take care of breaking down a lot of the different pollutants. So if groundwater is polluted, it is definitely problematic. So how does it even become polluted? Spills can infiltrate through the soil. Even something like nitrogen fertilizer can eventually, the nitrates could get into the soil, then into the groundwater. If you have a waste pond or a lagoon that's not lined properly, that can get into the groundwater. And then also thinking about how a lot of hazardous waste, for example, are stored in underground storage tanks. If those are leaking, if they start to corrode, or deep injection wells. So all of this could be problematic with your groundwater. So when looking at groundwater pollution, the key here is prevention, because it's very difficult to clean it up. Okay. So a lot of our water does come from groundwater, and some of it also comes from surface water like reservoirs. So when we talk about treating drinking water, which tends to happen when you have a municipal water source, sometimes you have a water purification plant, which might add chemicals or disinfectants to kill off any potential bacteria. Could use UV exposure, filtration like those life straws, or even flocculation, which is when you add a chemical that basically causes all of the other non-water things that are in there to clump together. So water treatment, something we definitely take for granted here in the United States, where we do have the Safe Drinking Water Act, which was passed in 1974, which establishes maximum contaminant levels for a whole bunch of different things. And then you have a case study looking at bottled water, which we've talked about in class. All right, and then of course, beyond rivers, lakes, and groundwater, we have all of our saltwater in the oceans that can be polluted. So figure 20-16 has a nice kind of summary of the sources and effects of ocean pollution. Ocean pollution can be a major problem because so many people live on coastlines or near coastlines, and that's expected to grow as the population continues to grow. And a lot of the sources are similar to ones that we see with freshwater, and some of the effects can be the same as well. Page 546 has a great case study that looks at the eutrophication in the Gulf of Mexico from the Mississippi River. So we talked about that in the fall, but definitely review it. Pay attention to the potential solutions and think about, could they work or could they not work? Speaking of solutions, we have a nice breakdown of coastal water pollution solutions, both prevention and cleanup. When oil and petroleum get in oceans, a lot of times we think about these major incidents like the BP oil spill or Exxon Valdez, which happened long before any of you were born, but oil can even get in from much smaller sources as well. When oil and petroleum ends up in oceans, problems are like the VOCs, those volatile organic compounds, can kill animals. All of the oil that kind of forms these like tar-like globs can affect their feathers and fur and make it so birds can't fly or animals are not insulated. And then the really heavy components will actually sink to the bottom, and they can smother the bottom dwellers that live on the ocean floor. So ways that we can clean up oil spills includes using like skimmers or floaters, absorbent devices, burning the oil, and chemical dispersants as well, which kind of help to break it up. All right, so how do we deal with water pollution? Key thing, especially for our non-point sources, are changes in agricultural practices. So think about all of those things we talked about in our previous unit with agriculture and how those, like, for example, reducing sediment and fertilizer runoff, so reducing soil erosion, those are all really important when it comes to keeping our water clean. In the United States, we do have the Clean Water Act. What it does is it sets standards for allowable levels of pollutants, and for point sources, it requires permits for polluters. So they have to basically make sure, and those permits have to be renewed. So our water treatment plant that we have right near the high school has a permit and they have to constantly measure what's coming out of that plant and into the groundwater. Another law, which was and then was not, in January 2017, then President Obama passed the Stream Protection Rule, or signed the Stream Protection Rule, which was under the Surface Mining Conservation and Reclamation Act, but then President Trump revoked it in February of 2017. What it did is it covered waterways that were near surface coal mines and helped to restore streams that were damaged by heavy metals. But we'll see. Maybe it will come back. All right. Page 550 has a nice diagram showing how your septic system works, because you have one of those at home. So definitely read about it. We'll talk about it in class. Maybe you've been present for when your septic tank has been cleaned out before. Lucky you. But it literally does separate into, it's called a scum layer and a sludge layer. And then the wastewater goes into your drainage field, where hopefully then there are a lot of nice healthy bacteria that help to break down anything else. And the tank is what's getting cleaned out. Do need to know what happens in a wastewater treatment plant. I'm hoping we'll be able to go visit the one on our school campus. Basically, we can divide it into 3 major stages of treatment. Primary is physical treatment. These are things like bar screens and the grit chamber, the settling tanks, where just basically heavy solid things settle out from the liquid. The second stage is secondary treatment. This is biological. This is where bacteria are going to break down a lot of the biodegradable wastes, kind of like what can happen in your drain field. Primary is very similar to what happens in your septic tank. And then third is tertiary treatment, which can be a combination of both chemical and physical. And this is when phosphates and nitrates are hopefully removed. And tertiary treatment is relatively new compared to wastewater treatment plants in general. And then there's disinfection, which is super important, and that's when either chlorine is used or ozone or ultraviolet light, and that helps to kill off any bacteria that remain. What a lot of cities have is their stormwater and their wastewater all end up going to a wastewater treatment plant in a single pipe system. This can be, so to stormwater, things going down like the storm drains in the streets. This can be really problematic when you have a period of really heavy rainfall, because the wastewater treatment plants may have to release some water that has been untreated. It's diluted, but still kind of gross. So it's better if you can have a dual system where stormwater goes one place and then just the sewage goes to the wastewater treatment plant. I love the science focus on page 553 about treating sewage with nature. And I'll show you guys pictures of the living machine on I-89 and the Vermont Welcome Center, because it's pretty awesome. And that is pretty much Chapter 20 in a nutshell. Read that. What can you do to reduce water pollution? Because it's always nice to make some individual differences yourself.